Let's integrate 10 square root of x plus 1. How do we do this? It's not easy to integrate 10 square root of something. So I'm going to let k equals to square root of x plus 1. Now, of course, I will replace k into square root of x plus 1 here. Then we will have 10k dx. We also need to replace dx with dk. So how do we do this? We have k in terms of x here. All I need to do is just take the derivative of k with respect to x. So square root of x plus 1 is also equal to x plus 1 to the power of 1 over 2. Now, dk over dx is equal to 1/2 times x plus 1 to the power of negative 1 over 2. And this is also equal to 1 over 2 times square root of x plus 1. Because the negative exponent will put this term to the denominator. Now, how do I isolate dx so that I can replace dx here? I just have to inverse this and inverse this. So dx over dk is equal to inverse of this, which is 2 times square root of x plus 1. Multiply both sides by dk. So we have dx equals to 2 times square root of x plus 1 dk. So I can replace everything here now. And that will become integral of 10. Now, square root of x plus 1 is k now. Times. Now, dx here is this. So times 2 times square root of x plus 1 dk. And we cannot have x here anymore because we're writing everything in terms of k. We know that square root of x plus 1 is equal to k here. So we can replace k into this here. Integral of 10k times 2k times dk. Okay, now let me move this one to the front and take the constant 2 out of the integral sign. I have 2 integral k times 10k dk. Okay, now we have to integrate this. This looks like a product of two functions. And you're integrating a product of two functions? Maybe you can consider using integration by parts. Now look at this. I can easily differentiate k, and I can probably find the antiderivative of 10k. So I'm going to make k equal to u, and this equal to dv. Okay, so now u is equal to k. Then du is equal to dk. dv is equal to 10k dk. Then v is equal to the antiderivative of dv, right? Integral dv, so antiderivative of 10k dk, right? So now, how do we find the antiderivative of 10k dk? That's the same as integral of sine k over cosine k, right? Now, with this, I can use the u substitution method. But since I use the letter u here, right, in the integration by part, I'm going to use a different letter. I'm going to let m equals to cosine k. Then dm over dk is equal to negative sine k. dm is equal to negative sine k dk. Multiply both sides by negative 1. We have negative dm equals to sine k dk. Now, I can replace sine k dk completely here, right? So now this will become this integral of -1 over m dm. And that's equal to negative ln of m. And we say m is equal to cosine k. So now that is equal to negative ln of cosine k. This is the antiderivative of 10k, which is v here. V is equal to negative ln of cosine k. Okay, now put everything together. Integral of u dv is equal to u v minus integral of v du. Now, integral of u dv is integral of k 10k dk, but we also have a constant 2 here. So let's put it here so that we don't forget. 2 integral of k times 10k dk is equal to, now 2 times, now u is k. So k times v is negative ln of cosine k. Here. Minus integral of v, which is negative ln of cosine k. Times du, which is dk. Okay, now we're going to evaluate this integral here. And this one is easy. So that's equal to 2 times negative k ln of cosine k minus, I will keep the minus sign here so that I don't net it out to plus. So ln of cosine k dk. Now, we just have to evaluate integral of negative ln of cosine k. But how do we do this? It's not easy to integrate this, because we know that at least use substitution method will not work. In this case, we're to introduce the Fourier series of negative ln of cosine k here. So here, negative ln of cosine k is equal to ln of 2 plus the sum of, from n equals to 1 to infinity, negative 1 to the power of n times cosine 2nk all divided by n. So this is the Fourier series of negative ln of cosine k is equal to this. This variable k is equal to k, right? Because this is k here, right? So we have to replace this with this. Okay, so here equals to 2 times negative k ln of cosine k minus integral of this ln of 2 plus the sum of n equals to 1 to infinity negative 1 to the power of n times cosine 2nk all divided by n dk, like this. Okay, now let me write it here so that I have more space. Equals to 2 times negative k ln of cosine k minus integral of ln2 plus the sum of n equals to 1 to infinity negative 1 to the power of n times cosine 2nk all over n dk. Okay, so here equals to 2 times negative k ln of cosine k minus, now integral of ln2 dk. So since we're integrating dk, ln2 is a constant. So I just have to write down ln2 times k. Now minus plus is still minus. Now integral of this summation here. So what is that? Notice that we're integrating dk. Every term will be the same except for n, because n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until infinity, right? So in every term, n is different. Everything else is the same. And since we're integrating dk, negative 1 to the power of n over n will be constant, right? So we're integrating this. So let me write it out like this. The sum of n equals to 1 to infinity times, what's the integral of cosine 2nk? It must be sine 2nk times 1 over 2n. Right? Because if you differentiate sine 2nk over 2n, you get cosine 2nk. Now, let me rewrite this. Now this will be the sum of n equals to 1 to infinity. Okay, we will group the denominator together. So we have negative 1 to the power of n times sine two nk over here 2n squared. Okay, now we finished the integral, but everything is in terms of k now. We have to rewrite everything in terms of x. So here, what did we say k is equal to at the beginning? K is equal to square root of x plus 1. Here, let me rewrite this. This is equal to 2 times negative square root of x plus 1 times ln of cosine of square root of x plus 1 minus ln 2 times square root of x plus 1 minus this. The sum of n equals to 1 to infinity, right? Negative 1 to the power of n times sine 2n times square root of x plus 1 divided by 2n squared. Okay. Now, lastly, we just distribute the 2. Okay, so that would be -2 times square root of x plus 1 times ln of cosine of square root of x plus 1 minus 2 ln 2 times square root of x plus 1 minus, now 2 times this sum, so 2 times the sum from n equals to 1 to infinity, -1 to the power of n times sine 2n times square root of x plus 1 all over 2n squared. Now we're done. Plus c. So this is the integral, right, of tan square root of x plus 1. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.